This is an A-level further maths question to do with complex numbers and the Argand diagram. So it says the point P represents a complex number in an Argand diagram given that modulus, I'll just write that down, it's a bit blurry this, modulus of z plus 1 minus I is equal to 1. Okay, I always get this in the form, I want to get this in the form z minus a equals b, and this is a circle, center A and radius equal to b. So let's get it in this form, so don't have too much to do here. It's going to be z minus 1 plus I is equal to 1. So that's a circle, center, minus 1, 1, and radius is just equal to 1. Now, we're only doing part D of this. It says find the greatest and least values, possible values of z minus 1. So before we do this, we want to do a sketch of this thing, this original thing here, so of this circle. So do a half decent sketch. So you've got your real axes and your imaginary axes. The center is minus 1, 1. So minus 1, 1 very roughly here. And it has a radius of 1. So that's minus 1, 1. A radius of 1 means it's going to touch here and it's going to touch here. And bear with me here as I draw a very bad circle. Very bad circle indeed. That's roughly what it's going to look like. So it's going to touch the positive y-axis at 1. And it's going to touch the negative x-axis, negative horizontal axis, I should say, real axis at minus 1. So that's what you've got. Okay. Part D, what part D says, find the greatest and least possible values of z minus 1. Okay, what on earth is z minus 1? Z minus 1 is the distance from the point 1 to, so that's 1, 0, to my z values. And the z values are basically every point which is on this circle here. So every point which is on that circle. So z minus 1 would be the distance from here, this point, which is going to be at 1, to this circle. Okay, seems easy, but it's not quite so easy at all. So what we've got to do is we're going to draw a straight line from this thing, the shortest distance, if you can imagine here, it would go, oh dear, that's terrible. Right, let me get rid of that. Right, the shortest distance, if you imagine, if I had a ruler here, that would be a big help. If you can imagine, I've got a straight line which is going here and right through my center. So it's cutting that at right angles. So you imagine if you had a tangent, that would be cutting at right angles. That would be the shortest distance would be from here to here. The greatest distance from this point would be the same thing, but it would continue along through the center. It would be this distance all the way from here to here. So the shortest distance I'll do in yellow would be this wee distance, and the greatest distance would be this distance in blue. Now, what we know is the radius. This distance from here to here is just 1. Likewise, this distance here is just 1. So it's a bit messy here. So what I'm going to do is find D, which is a distance. D equals the distance from minus 1, 1 to 1, 0. So I can do that just using my distance formula. So D is just going to be equal to the square root, and this is the y difference, x difference squared plus the y difference squared. So 1 minus 1 squared plus 0 minus 1 squared, and that's just going to be 2 squared plus 1 squared, which is just going to be 4 plus 1, which is going to be root 5. Okay, now my shortest distance, so that means what I have found here, if I just zoom in and show you what I've just found, I found the distance from here to here was root 5, which means that yellow distance is going to be root 5 minus 1. So the shortest distance then, shortest distance is going to be root 5 minus 1. That's an exact answer. And the longest distance is going to be, that root 5 plus another 1. So that's what the longest distance is going to be. So the longest distance is going to be root 5 plus 1. And that is it. So using a wee bit of geometry, the fact that the shortest distance to a circle will hit it at right angles and then therefore will go on through the centre of the circle.